We are recording. Welcome to the evening of Python coding. This time it's joint between the Austin Python meetup and the DC Python meetup. We would like to acknowledge our sponsors that help us many times as Capital Factory, Galvanize in the past in Python. This week, actually, it's supposed to be last week, but due to the weather in Texas, we had to postpone a week, and I see many from Texas arrived, so this means things are better now. So this week, or this event, Gary Cow is gonna tell us about a visualization library called Seaborn. We showed several visualization libraries in the evening of Python coding in the past, and also in the Python meetup. People who are interested can go back to the past, and Gary, I asked him to go and try to give the demo at the level that beginners can actually follow. So Gary, please start the demo and introduce yourself to people who want to know more about you.
Okay, thanks, Jacob. My name is Chongshen Kao, that's my original name, but I usually go with Gary. And I'm working for Johnson & Johnson as a data scientist right now. And I was studying my PhD in UT Austin from 2013 to 2020. So I basically just moved out to Austin. And thanks to Jacob and a lot of folks from the meetup, they help a lot of people to learn the Python and everything related to Python. So I will just jump into the topic, the seaborn. And I believe Jacob has shared the link with all of you guys, so you can follow along or just check the thing I'm sharing right now. So today I'm going to talk about this alternative plotting package, seaborn. I believe, and also put the version and the reference here. And in their official website, they have a lot of great user guides for people to follow. So if you are a beginner, that's the best place to go. So I believe most of you should be familiar with these basic packages like pandas, numpy, and even the basic plotting package, matplotlib, pyplot, and usually the abbreviation is the PLT. And the seaborn I use here, I would just use the SB as a short abbreviation. And I will start with the data structure to illustrate the ecosystem in this seaborn package. So there are two types of the data you can form, like the long form data, just like the table here. You have the index as numbers, and you have many columns. Here I just use 3. You can have categorical variable or the numerical variables. And we also have another form. We call it wide form data. So basically, you have a detailed information in your columns, and also the detailed information about year in your index. So you probably already can see the biggest difference between these two forms of data is how many variables you can use. And for the long form, you can have as many as possible you want. But for the wide form, you basically only can have 2 features. We also call it variables, like month or the year. So this is certain restriction between these 2 data forms, and it's also related to the seaborn packages. And I can show you what's the difference. So when we try to plot with these 2 data structures, if it is the long form data, there is a lot of flexibilities you can do. So this is the relation plot under the seaborn. I call it SB, so we can code it out easily. And I'll talk about this later. And the major purpose of this real plot is the relationship between two variables. So for example, the year and the passages. So you can see that these two columns are the numerical values. And we want to see what's the relationship between these two. And we also can add some conditions with it, like the month. So month is a categorical. This is not a value. So we can use the hue, and you will assign different colors to each categories in the month, like January, February, etc. And then the kind is where you can choose how you want to present this plot. So the other option is the scatter. So you probably already know the scatter means multiple dots instead of the line. But these two different visualization will give you different perspective. So it depends on what you want. And then you also need to indicate the data where it is from. So you usually will read some CSV or Excel file into a variable. We call it flats, and then you can put it here. So seaborn will recognize the data and try to pick up the columns as the x-axis or the y-axis. And then let's see how does it do with the y-form data. So if you use the y-form data, this relation plot can recognize each variable directly. You don't have to assign anything, and you only need to tell the seaborn what kind of the relation plot you want. So here you use the line, so it basically show you the similar visualizations like previous one. You also assign the colors to different categories in the month variables directly. So you just need to assign the data and the kind parameters. So this is the biggest difference between these two data structure. And another critical things in seaborn is the figure level and the axis level functions. And if you are familiar with the matplotlib pipeplot, you're probably also familiar with these two terms. So basically, figure level functions include the facet grid that's similar to the subplots from the matplotlib pipeplot, and which means you can plot multiple subplots within one figure. And in the seaborn, it also means it can wrap multiple single plot functions. So for example, the relational plot I just showed you, the red plot, it includes the scatter plot and the line plot. That's where we assign the scatter and the line in the kind parameters I showed previously. So you can just assign this and to get the plot from the relational plot. And another two major category is the displot, which is the distribution, and the cat plot, which is related to the categorical variable. So you can see there's a lot of different axis functions under these figure functions. So I will just focus on the displot in the demonstration, but you can definitely find a lot of resources from their official website about the categorical plot. So distribution plot, it has 4 different major categories: the his plot, which is the histogram, and kdeplot, and ecdf plot, I'll explain later, and the rock plot. So
Gary, before you go on, can I ask a question?
Sure.
Go back to the diagram. What's the main difference, like between the relationship plot is like the line plot, like an XY plot you usually people know, like a simple graph, correct?
Yeah.
This plot is what? Like a histogram, correct?
Yes. So distribution is like the counts of each categories you have. So it's basically just histogram, but you can have different ways to present it.
Okay.
Like the KD and ecdf.
Okay. And the categorical plot, what is it? It's bar plots or what is it?
Yeah, so it includes a box plot and bar plot. So it basically try to calculate how many categories in your categorical variable, like the month I showed you before. So here it can show you how many rows and belonging to certain category and show it in the categorical plot. If you try to focus on those type of the variables.
And will it be correct to say that if you look at the differences between those plots, so the relationship plot is where your x-axis is continuous, the categorical plot is where your x-axis is categories, and distribution plot is something in the middle that some statistical creature with categorical x-axis. Is it correct?
Yeah, that's correct.
Okay.
Yeah, thanks for the collaboration.
Hey, Gary.
Yes.
There's a question. Why is it a January solid while other lines are dashed?
Yes, so that's another internal functional setting. So among all of the parameters, you can also choose different types of the lines you want within this, but I just didn't show here. That's one of the parameters. It's called style. So if you have more conditions you want to assign in one plot, you can also use it in here. But for the wide form data, it assigns it automatically. So that's why you see those different styles.
Okay. Thank you.
Yeah. So for demonstration, I would like to show the long form data particularly because I feel like it's more flexible for people to use it in their routine data analysis or visualization. So for distribution plot, you can do univariant, which means a single variant, or multiple, or just two. I'm gonna talk about it later. So we started with the univariant, which means you only have one variable you want to check. So people should be familiar with the histogram. That's what it is. And the data we use here is the penguins, and you can load it from the seaborn. It's stored internally in the seaborn packages. So you can just use the load dataset to find it, and then you use the head to read the first 5 rows. And you can see many columns. It has the categorical variables, and you also have numerical variables. So it's pretty useful for the demonstration. So for the typical histogram, we can just use this plot, and the default is a histogram. So you don't need to assign anything, but you still can type it if you want. So data is the penguins, and we would like to check the flipper length column. So you can just assign it here. Then the plot will show you the count of each bandwidth, like 180 to 185 or 190 to 195. And you can see the distribution of each different flipper length. and you can also to add some conditions with it. So we can see there's many species in this penguin dataset. Then you can use the hue parameters to assign the species, and everything else is the same as the previous one. Then you can compare the distribution among these 3 different species. But you can easily to tell it's not the best way to show it because there's some overlappings between these 2 species, the blue and orange. So it's hard to figure out which is which. Then we can use some further parameters, like multiple parameters, and just choose dodge. Then you can separate out those distribution, and then you can easily to see the comparison between the species.
Gary?
Hey, Gary.
Yeah.
Go ahead, Jacob.
I was curious about the previous plot when you don't say the order when there's one on top of another. So are they overlapping? Because I see sometimes you can actually see behind, like this yellow bar, you can see what happened behind it, but you cannot see something that happens behind the gray one. Is it the order there something you can control, or is it just decided by the? How does it go? The transparency there.
Yeah, so the gray part is the overlapping area, and it's hard to know beforehand because you just get the data and try to visualize it. But you do have the power to change the order of these species, and also includes in this plot in one of their I think it's hue order, and you can assign different orders as you need.
Interesting. Thank you.
Yeah.
Jose, what was the question?
Yeah.
Yes. Why use matplotlib or seaborn when Excel gives a much wider variety of graphs?
Sorry, which graph?
They're asking why do we use matplotlib or seaborn when Excel gives a much wider variety of graphs?
Oh, so the varieties means you mean you have more options, or you mean I don't really know what does it mean varieties.
I'm guessing they have more modules. Excel has more modules to display the metrics and visualizations, and more than seaborn or matplotlib.
I don't really know that though. I feel like it's more flexible in seaborn and matplotlib, and in Excel, I think it's my personal experience. So I'm not an Excel expert, but I do use a lot of Excels when I was in PhD before I get in touch with Python or R. But you don't have a lot of flexibilities with the access or anything you see in this plot with the Excel. A lot of setting is already set beforehand, but it's pretty user friendly because you can just click whatever you need and then the plot will show up. But sometimes if you want to change how wide it is or how the ratio of your x-axis or y-axis, it's hard to adjust it compared to the R or Python visualization package. That's my personal opinion.
Yes, I actually had some type of a little bit of experience on seaborn and matplotlib myself. So, like you said, it is like easier and user friendly for people that barely know Python, and you could actually just put in, like you said, a CVS file or Excel spreadsheet into the function and just put in 2 or 3 parameters, and matplotlib does its work and will display that information for you. So, yeah.
Does it have other questions or?
Yes, there is. Is there? I'm sorry. Excuse me. If there is no numerical data in some column, does that mean it's going to be a categorical variable by default?
So does it mean the NaN, or does it mean, is it asking the difference between the categorical and numerical, or just the missing values?
I'm guessing if there's a column without a variable in it, by default, what does that mean?
Oh, so this is the missing values. It means sometimes, you know, in the data set, we didn't record that data, or we don't have that data. So basically, it's empty. But in I think in Python, you will just assign. So for the data set, you will just assign an NaN. But for the visualization purpose, you will just skip it. So it won't cause any troubles. So ignore those missing values and use the rest of the values to make the plot.
Hi, that was my question. Like, I'm not talking about the NaNs, like the name, like the species or the sex, those kind of things. Like, if in case you put some sort of word or something, does it automatically take it as a categorical variable? That was my question.
Yes.
Okay.
Yes. Yeah.
Okay. That was the default setting.
Yeah.
Okay. Thanks.
No problem.
That's it. Thank you, Gary.
Sure. So let's get back to that. So we can use these multiple parameters and just separate out those different species. And it's really convenient. As you can see, we can start to see different distribution just by using the colors of them. And then we have a more sophisticated way to do it. So this looks more like a subplots when you use the matplotlib pyplot. So everything is the same. The data set, penguins, and the X is the variables we want to check. And here you just need to assign another color variables as species. So it separates out these species into 3 histograms. Then
I think it means column.
Yeah, it means column.
Yeah,
Yes.
no, not color.
Yeah, this is column. Sorry. Yeah, so you can see that this is the first column, second column, and third column. So it depends on how many species you have. It will just directly assign to different columns. And you can also control the colors of it. Even you see they're all in the same default color, but it's all, you can manipulate all of this by yourself.
Nice.
Yeah. And then to the kind parameters I mentioned previously for the relational plot, the distribution plot, it also has this power to change your histogram to other forms. So it includes the kernel density estimation KDE, and also empirical cumulative distribution EDCF. So when you assign this plot, the kind parameters in these plot functions as the KDE or the ecdf, basically is equals to the axis functions we talked about previously. Just you can call KDE plot directly from the seaborn, or you can choose this way to do the KDE plot. The same thing with the ecdf. So here we use the same thing, the penguins and the same variable, and we choose the KDE in the kind parameters. So now you can see a totally different ways to visualize the same graph. So it's smoother, and you can see the highest point and the lowest point and the intermediate point. And just one thing to be aware is the scale is a little bit different. Now it's the density. So the overall values will be 1. So it's sort of a normalization it does automatically in this KDE plot.
Hey, Gary, going back to the previous plotting graph,
Sure.
there's a question. How did you create those subplots or different panels?
Different panels. What does it mean, different panels?
Hi. So basically, I see these 3 different plots, 3 different histograms, one after another.
Yes.
On the x-axis, like in the horizontal, like 3 different panels. So how did you create those 3 separate ones? Like, what's the command, or how do you set it up?
Oh, you want to have 3 plots instead of?
Yeah, like you put 3 different,
Yeah.
the histogram sets, right? Like one is a species Adele, one is a species Trap, another species Gen 2. So these 3 different, subplots or panels. I don't know what you call that, but
because we declared the column as species, I think that's why we have 3 column plots there.
Yeah.
Okay, I see.
If you want each of them individually.
Okay, you have 3 different species.
Yeah, there's 3 different species.
Okay, I see. Thank you.
Yeah, it's 3. Yeah.
Thank you.
Of course.
Yeah, whoever explained it, thank you.
You're welcome.
So for the KDE plot, we also can add some conditions. So you can just add the hue parameters as species. Now you can see this clear distribution, blue, orange, and the green one, and you can easily to know which species has a longer flipper length compared to 2 other species.
You can also see how many of them. Like you can see
Yes.
that there aren't that many oranges because they all sum up to 1 according to what you said.
Yeah, so you can also tell the amount of each species. Yeah, thanks, Jacob. And then you also have some another options that you can combine both of them if that's something you prefer and you think it's easy to tell your story. So you can just add the KDE equals true. So as I mentioned previously, the default is the histogram. So you don't have to assign anything here. You will have the histogram in the backend. And then you just need to tell this plot that I also want the KDE. And the default setting here is false. So if you don't assign anything, you won't see this KDE plot with it. And another options is the ecdf. So basically, it gives you a proportional accumulation of your variable. So the total will be 1, which means 100%, and you start from 0% to 20, 40, 60, and eventually will comes to the 100% of your data. So it's the same thing, the same variable and the same data set. We just need to assign ecdf under the kind parameter. Then we can use the hue parameter again, and then you can see how they accumulate in different flipper lengths. So now I would start to talk about the distribution plot if we want to visualize some more than one variable. So here we call it bivarian, and both of them are the continuous variables. So here is the data set again. here we choose the build length and the build depth. So these two columns. And you can still see the missing values, but the seaborn will ignore it directly. So here you can see that this plot will give you sort of like a density plot.
There was a question there, Jose. What was the question that Sherry asked?
Yes, thank you, Jacob. She's asking, what is meant by flipper lens? Yes, flipper lens.
I think it's just the penguin's foot, and how long is that?
Okay.
I guess that's. I'm not familiar with penguins, but I guess that's the thing.
Sherry, the next time we'll ask about the Titanic dataset. It's much more morbid than penguins. Penguins are much more fun.
Hey, Gary.
Yeah.
I want to share this a little bit. So my brother-in-law, he's a director of a big distribution warehousing company, and he's in charge of the distribution part. They're really big in data analysis. So basically, making their truck drivers deliver their product to businesses with time efficient and saving money, saving costs, and being able to make more deliveries in like more in one day using data analysis. So that's what he was telling me. They're really big on that. And that's just the warehouse. It's not an IT company, but that warehousing needs data analysis for that type of metrics, so they could improve cost and time, and yeah, for their company. So just wanted to say that.
Yeah. So if it's not related to visualization, we can talk about it later.
Oh, okay. Yeah. Well, I'm guessing they were using Seaborn. That's why, for data visualization.
Okay.
Yeah, I believe there will be a lot of distribution plots related in their business purpose, for sure.
Yeah.
Okay. Sorry about that.
No, that's fine. That's fine. I was waiting for the question related to visualization. This is why. But we'll talk about it later.
Okay.
Don't forget, we'll talk about it. Sorry, Gary, go ahead.
Yeah. So as you can see, it's similar to the scatter plot, but it's not the same, right? So the x-axis is the build length. It's one of the continuous variable, and y that you assign another continuous variable build depth. So it shows you the density of each area, and if it's darker, it means there's more, and if it's lighter, it means it's less. So personally, I don't really think this is a great visualization. So sometimes that's why you can also have other options here. So the kdeplot can be also used in the bivarian visualization. So here you use the 2D Gaussian to smooth out the plot a lot. Then basically the same setting, but you just choose different kinds as the KDE. So it's more like a contour plot that we usually see in many like geology area or the field. But if you also when you in the top of it, it means the density is higher than others. So it depends on which direction you want to go and how you want to present your data. You can have really a lot of options with the seaborn. So this distribution plot functions is not only limited to the continuous variables. So if you have the discrete, which is the categorical variables, you also can make some plots with it. So here you just need to assign the categorical instead of the continuous variable here. So like species or the island. So we want to know what kind of species will be in certain island. So here you can see that most of the Gento species will show up in the Bisco Island, I guess, and this bar represents the density level, and it's easy to follow, and it's basically tells you every information from the data set. And for this bar, you can just use the C bar parameters and put it true with it, and you can see that. So the default is false. So if you don't assign this, you won't have this color bar. Then that's getting to a more complicated area. So we have, I have shown you many different plots like distribution plot, scatter plot, histogram, and this particular method under the seaborn, the join plot, can give you both of them at once. So sometimes you want to tell a story with many different plots, and it fulfills that wish. So this is just use the join plot under the seaborn and assign data, saying which x-axis you want and which y-axis you want. So it basically give you the scatter plot and the histogram on both sides. So you can see the distribution with one of the univariants, and also see check another variables distribution from the histogram. And in between, it's the bivarian scatter plot. So you basically just use one single plot, and you include many different visualization. And of course, it also has the hue parameters that you can assign the conditions. So now it is getting more complicated. So another level's information here is the species. So you can see Adelaide species, they all have a smaller bill length and shorter flipper length. Compared to the Gento, they usually have longer bill or longer flipper. So that's the power of the visualization you can use for the presentation, or if you want to talk to your manager or somebody else, they don't understand the data, they can just use this single plot to understand what's going on. And then, of course, until this point, you might think, if I have a lot of variables, how are we going to do it? So seaborn also has this pair plot. You can plot many distribution at once. So you basically just give it the data as an input in this pair plot function, and it can show you all of the numerical variables, which is the continuous variables at once. And you can have a scatter plot between two different variables. And you can also, in the diagonal direction, you can have the univariant histogram for each of them.
Hey, Gary?
Yes.
Kenneth Stallworth has a question. It is asking, in real-world projects, where does the data usually come from to run the charts?
It depends on the company. Some companies, they will have a database they can query from, like an SQL database that companies usually use. And sometimes they will buy the data from other resources. So it depends on how the companies want to do their business. I hope I answered the question.
No, yes, I understand exactly.
Okay.
Yeah, that's it.
Okay.
Thanks, Gary.
Yeah, sure. So this is the final one. So yes, we're gonna talk about the hue again. So as you can see, this is a more complicated and more information plot, but it's very useful because it's colorful and it's easy to tell the story. So here you basically just assign the hue parameter as species. Then you will have all of the distribution comparisons and the scatter plot comparison at once. And you can see the relationship between species, and then you can see whether there's outliers or certain type of the weird distribution, or you don't get any variation from those distribution. They are aligned in the same area. So I believe this is the most complicated one you probably can do with the seaborn. But just another things I want to mention that you don't really want to use many features with the pair plot because it will run really slow, and then sometimes it will also crash sometimes if you use like 40, 100 variables. So here, just be careful. You want to use probably around 10 variables the most, instead of more than like 50 or 100 variables. Just one little note. And that will be all of my demonstration. So if you have anything you want to discuss, or if you have even other things not related to visualization, I can talk about too. Yeah, thanks.
Gary, there's a question. So why learn seaborn as opposed to, say, plotlib? Any difference in learning curve, usability, better for certain type of applications?
So based on my experience, I think matplotlib is really powerful, but sometimes it can become really complicated with the setting, and because it can goes into very detail in the visualization in certain plot. But for seaborn, I think it makes it easier. I think a little bit more user friendly if you understand the logic of it, like the long form data, wide form data, and also the figure level and the axis level functions that I show here. I believe it's easier to learn for the beginners. But if you want to, make a really complicated and really customized plots, you definitely want to also learn about the matplotlib. So that will be my answers. And also, I feel like the colors from the seaborns is a little bit better than the matplotlib. That's my personal opinions. I don't want to offend anyone.
No, I agree. I think that's an opinion.
Gary, you're not offending. Those are all libraries that exist. Actually, seaborn is one of the older ones. Matplotlib was there, one of the very basic ones. And today, what happened, since Matplotlib is versatile, people started building on top of it. So seaborn seems to be one build. Now they are building on top of multiple libraries. There are several primitive libraries like matplotlib. There's also bokeh now that provides primitives. There's also plotly.
Yeah.
And on top of it, there are all libraries that build on top of those. So this seaborn is one, it's built only on top of matplotlib, but today there are libraries, and we talked about all of his libraries that build on top of others. Recommendation, use whatever library you are comfortable with and but if you need special features, sometimes one library or another can give you features that don't have in the other ones, and they have their own complications and their own simplicities. Gary showed you some of the things that are simple in seaborn. There might be others.
Yeah, the matplotlib is definitely the backbone of the seaborn package, and I hope this GitHub link can give you a great starting point if you can just follow some of the codes here and then use your data and try to visualize some of your some of your projects. I hope it will be helpful for you.
I have a question, Gary. Where do they get information about more documentation or stuff like that? So you have the demo, but like the Seaborn website, or there are some examples. Where do you get more documentation on Seaborn if someone wants to learn more?
Yeah. So I think the best place you can go is their official website. They have a lot of great tutorials you can follow along. And honestly, I still a lot of their tutorials for today's demonstration. So you probably can see a lot of similar things. And I would definitely recommend to go through the user guide and tutorial first.
Yeah, okay. So there are tutorials and there are ways that beginners can start learning it, because we have many beginners.
So I think if you want to learn the ecosystem, you can start from the top of here. So just click the tutorial, and there are like two major sections on the top of the web page, and just try to read through some of those. And I also point out some of the bullet points here, but you definitely can go through it quickly, and then you can. And next, you can choose which kind of the plot you want to go with, and you have different sections. Like if you want to know more like a statistical relationship, you can go to this section. And if you have a lot of categorical data you want to show, like the bar plot, you can go to this section. And if you want to learn the last part of my demonstration about multi-plot, you can go to this. It has a lot of custom functions you can learn, and also it give you a library, I think a gallery of it. So you can also start from here, because this is the graph, so you can easily to define which one you want, and then it will provide some of the all of the codes underline, and you can try to use your data and redo it again.
Okay. I have no more questions. Anyone has questions still left? Questions going once?
Hey, I had a question. Like, how's data structured so it fits into the graphs? I mean, are we using like numpy arrays or dictionaries or something? Does it make sense?
I believe you want to use the dataframe from pandas.
Okay.
So I'm not sure whether you can use numpy. I think you can still use a numpy. Let me double check. I usually use pandas, so.
Explain the difference for the newcomers. What's the difference between numpy array and pandas? Some don't know the difference. Just in a few words, nothing elaborate.
So I think for the pandas, it's constructed by the series, and numpy array is more like a multiple list within a list. Based on my personal experience, and series is a specific type of kind of list in the pandas data frame.
Okay.
I hope that explains.
For newcomers, check out what Google Pandas, Google NumPy, and NumPy Array, and you will see the difference. But it's important to know that probably you can work with both of those datasets. I assume it will work with Python lists as well, correct?
Yep.
Okay. So it's pretty standard of all of those visualization libraries to support multiple types of data structures, I would say. not only data. Here.
Yeah. So and to answer your question, I think you can use dataframe, numpy array, or list of the arrays. So probably not dictionary directly, but you can transform the dictionary to the pandas dataframe directly.
Yeah.
And then use it. Yeah.
And for those who don't know how to present data as a dictionary, we'll look up at other talks, but basically it's how you present data, and the dictionary is a way to present data. I'm telling this for the newcomers here, who probably getting confused a little bit. But basically what Gary is trying to say is this is very versatile. Okay, so Gary, this is your LinkedIn page if someone wants to join or say hello to you.
I'll just try to add it to the chat if you want to connect. I'm happy to talk more about Python.
Okay, so Gary invites you to talk more about it in his LinkedIn page. Someone asked about the GitHub, how do you access the GitHub? In the recording you'll see the GitHub link on the top. I noticed there was a question. The link to this demo. Unless someone else has really pressing question, I suggest we finish this. So, question going once. Yeah, I see something. Someone is asking something, or is the discussion? What's going on there, Jose? Was the question, or?
Yes, Gary. What IDE did you use to run the seaborn code and see the data visualization?
I used Jupyter Notebook.
Right.
And recently, yeah, they also have the Jupyter Lab. I feel like that's useful too. It's just a advanced version of the Jupyter Notebook.
Understood. Okay.
Yeah. Thank you. I couldn't find.
Let me check some questions. Where's Julie Rogers is asking, maybe address the size of data sets can be used in Seaborn versus Excel?
The size? You mean how big it is?
Yes.
I think it's related to a question asked before. Why don't use Excel just use this? So I think, yeah. Yeah, Excel has limitations. If you ever try to do more than 16,000 columns, you'll see where the Excel breaks. This is one example. Or I think it's 1 million lines also. So maybe she's saying this about maybe seaborn. I'm not sure. Well, what's your answer? What do you think, Gary?
So when I learn it and when I start to love the Python and R, it's because I can control everything I see instead of I have to follow Microsoft Office rule and just, I cannot do a lot of stuff I want. So I think that's the biggest reason for that.
Okay, Julie, one more reason to do this. In Python, you can automate this to have it the data manipulated before you actually load it and stuff like this. In Excel, usually once you do a plot, later you have to copy and paste things. So if you need to do 10,000 plots that are the same, it kind of becomes cumbersome. You have to write code anyway, which is a little bit cumbersome because it's using your macro language and you have to have Excel and stuff like that. And also there's some size limitations on data. Usually the Python doesn't care about the size, usually as long as your machine has enough memory to load it. So there are some reasons why use Python and not use an Excel spreadsheet. But Excel spreadsheets are great for some other things. So
I just think it might also be because of the advantage of being able to do programming, as visualizations along with programming.
Yeah. I see Gary is showing he's showing Plotly now on screen. Plotly is another one of those. There are libraries on top of libraries of visualization. So this is one of them. Plotly, we might want to bring some, actually we have someone who's going to show Plotly, I think at the end of in June. We already showed several others. Check out Holoviz in the past. Holoviz also does several of those most advanced plotting libraries. They are getting more and more advanced, more and more interactive. They are great. I'm using some of them for my own work. In the future, nothing is going to be Excel anymore because Excel is not interactive. Unless Excel becomes interactive, but that's a different question.
I think that Inactive Visualization is the next step. So I use a lot of this kind of plot for our company right now because users can easily to manipulate it by itself and interact with the visualization without the creator on the side of it. So it's another upper level, advanced level of the Python can do.
Yeah.
Yeah, another advantage, you can actually create like web pages that can be shared like within an organization, like and then you can get like real data. For example, you can get something from a database with the real data that comes in, and then it can be easily shared within an organization or like customers or stuff like that. So I think that's a big advantage than having a Excel spreadsheet.
Yeah, and you can have those static as well. But this is a different library, not about seaborn. We're confusing people. But yes, we can do it with Python.
In general, I'm talking about like all these visualizations in comparison to Excel, like gives you that advantage of being able to create these like dashboards that you can have a link to them, and then you can get like real data coming. And sometimes more like general terms when it comes to these visualizations compared to Excel.
Yeah. But then again, Seaborn is a little bit one of the older libraries. What is shown now is one of the newer ones. Unless someone has real pressing questions, we're gonna stop the recording and go on. So, last question going once, last question going twice. Zeppelin? I don't know. This doesn't sound like a question. Last question going. Okay, 3 times. No one has another question. So Gary, in that case, I want to thank you for showing all this nice stuff for us and extending this to the level of beginners can understand. So thank you very much. I'm going to clap in front of everyone. But anyone who wants to unmute yourself and clap, they're welcome.
Happy to share.
Yeah. And we're going to stop the recording. Don't go away. We're not going anywhere. Just stopping the recording.